Today we're going to be going over the circuit for our ESP32 version of the line tracking robot in detail. Let's get started. Alright, to begin with, at the bottom of our breadboard, we have our tuning pot right here. This tuning pot is used to calibrate our line tracking circuit, and the first connection of the tuning pot goes over to our 3.3 volt rail, which you can see connected right there. This red rail is 3.3 volts. This blue rail is ground. And then over here, this red rail is 5 volts. The other side of our tuning pot goes into the ground connection, which you can see there. And the center wiper for the tuning pot goes into our pin 35, which you can also see in the code over here. Doo-doo. All right. Moving up from that, the ground connection also is made to our little USB power provider. When we're doing the op-amp only version of the circuit, this is how we power the circuit. But we want to make sure all the connections are made at all times, so we have the 5 volts from the VCC coming out of this module going into the 5 volt rail. The 5 volt rail also feeds our operational amplifier. The other side of the operational amplifier is the ground connection, which you can see here. So VCC is 5, and the op-amp receives ground as its ground reference. So here are the two outputs of the operational amplifier, which are connected with just a wire to the negative inputs of those amplifiers, creating a unity gain amplifier, meaning that the voltage that we feed into the positive side of the operational amplifier will come out the output at much higher current. So that's how we're going to drive our motors, that higher current. You can only do a few milliamps coming out of the ESP32, so this is going to amplify that circuit for us, or amplify that signal for us. Now, connected to the unity gain output is the 1 and 2 motors. This is the motor connected to input 1, or operational amplifier 1. This is the motor connected to operational amplifier 2. You'll notice they have two different colors on their wires. That's because we want one motor to turn clockwise and the other turn counterclockwise in order to make the robot move forward. Forward being the direction that we want everything to move to line track successfully without having to do some other special circuitry. We simply swap those two wires and they both go forwards. Moving up the circuit, we have our 3.3 volt connection coming out of the 3.3 volt regulator built into the ESP32, going and feeding 3.3 volts to our rail. Pin 35, as we mentioned before, is connected to our tuning potentiometer, but pins 32 and 33 are connected to our line tracker, which you can also see in the code here. Pins 25 and 26 are DAC outputs, digital analog converters. This is the ESP32's analog output signals. These analog outs are fed into the operational amplifier in the in plus pin, and this is the signal that the amplifier is going to amplify and come out. You'll note that because it's a 3.3 volt chip, we can only do 0 to 3.3 volts, even though this amplifier is being fed with 5 and could theoretically do 5 volts. These motors do not need to be going that fast, and you're not going to get good line tracking if you try to go anywhere near that fast, so limiting it to 3.3 volts is fine. If you needed to go faster, you could just change the ground reference on the other side of the motor, but we're not going to be doing that, so we don't need to go into that in detail. Next up, we have the ground pin of the ESP32, which we connect over to the ground rail of our power rail of the breadboard. And you can see over here, this is the ground reference for one of the line tracking sensors, and over here, this is the ground reference for the other line tracking sensor. the positive voltage on the 3.3 volt rail and the positive voltage on the 3.3 volt rail. Let's take a look at those sensors. Mounted sensor side towards the ground, very important, with our pins coming off the front of the thing, which you can see there have been soldered directly onto our board. Note you do need to solder them. You will not get good connections just by wrapping that around there. Alright, and so with that, our line tracking robot should be able to follow a line. So let's find out how true that actually is. Alrighty. I'm holding the wheels off the ground while I plug it in because we don't want it driving off on us. And so when I put this down, it should follow the line. Good. And I'm just messing with the tuning pot to get it just fast enough to go because I want it to come pretty close to stopping at the end, but it looks like the sensors are just ahead of where it's going to be able to stop on the line, so that's fine. Let's see if it goes the other direction. And note, because it's a curve, we can test going both directions. On this side, the wheel does not fall off, and so the robot stops right at the edge, like a good line tracking robot should. Let's try that again. I just biased it to the inside of the line slightly. Nah, that line's too close to the edge. It's just going to keep falling off. But it does follow the line regardless. There you go. A stopping line tracking robot. All right. So, thank you for watching.